In this video, we will be looking at exponential expressions. We're going to start by looking at some laws of exponents. These are going to be true for a not being equal to 0 and b not being equal to 0. First up, we have the product rule. If we have a raised to the x power times a raised to the y power, that will be equal to a raised to the x plus y power. So for example, if we have x squared times x cubed, well, x squared is x times x. We want to multiply that by x cubed, which is x times x times x. If I multiply those all together, I have 1, 2, 3, 4, 5 factors of x. So that's x to the 5th power. And you can see that if we add the exponents like the rule says, we get to that place as well. Next up, we're going to look at the quotient rule, which says if we have a to the x power divided by a to the y power, that'll give us a raised to the x minus y power. So for example, if we had, say, x raised to the 5th power divided by x squared, well, if I were to write that out, that would be a fraction, which has 5 factors of x in the numerator, and 2 factors of x in the denominator. So if I divide out the common factors between the numerator and denominator, 2 factors of x are going to divide out, which leaves me with x times x times x. That's x cubed in my numerator. So if we subtract our exponents, 5 minus 2, we see that we get to x cubed that way as well. Next up, we have the power rule that says if we have a raised to the x power raised to the y power, that'll be equal to a raised to the x times y power. So I want you to consider if we had, say, x squared in parentheses cubed, well, that would mean x squared times x squared times x squared. And if I use the product rule that we had before where we just add our exponents, 2 plus 2 plus 2, that gives us 6 factors of x. So this is x to the 6th power. So you can see if we have a power raised to a power, we're going to multiply those. Next up, we're going to look at the power of a product rule, which says if we have ab in parentheses raised to the x power, we get a to the x, b to the x. So what if we had, say, 3x quantity squared? That would mean the same thing as 3x times 3x. 3 times 3, that's 3 squared. X times x, that's x squared. And that simplifies to 9x squared. So you can see if we have two things multiplied inside of parentheses raised to a power, we can distribute that power to each of the factors inside. But notice that there is no addition or subtraction in those parentheses. That's really important. This power of a product rule only works if everything is multiplied inside of that. Next up, we're going to look at the power of a fraction rule. A over b raised to the x power is equal to a to the x over b to the x. If we had, say, x over 4 quantity cubed, that would be equal to x over 4 times x over 4 times x over 4, which is x cubed over 4 cubed, which simplifies to x cubed over 64. So if we have a fraction raised to a power, we can put that power in the numerator and denominator separately. Next up, we just have some basic rules that you just kind of need to know. The 0 exponent says that anything raised to the 0 power is equal to 1. Remember, we do have the exception that a cannot be equal to 0. So 0 raised to the 0 power is undefined, but anything else, if we raise it to the 0 power, is equal to 1. So if I had, say, 3 to the 0 power, that'd be equal to 1. Finally, we have the negative exponent. A to the negative x is equal to 1 over a to the x. So an example of that would be if I had x to the negative 2 power, that would be equal to 1 over x to the positive 2 power. These rules are all really important, so make sure you are keeping these in mind as we work to simplify some exponential expressions. So we're going to take a look at some examples that we want to simplify. First up, we have 2 to the 9th times 2 to the negative 3rd power. I have two numbers being multiplied by each other and they have the same base, the big part. That means I can add my exponents. So this will be 2 raised to the 9th. But to that 9, I want to add a negative 3. Because they're multiplied, I add the exponents. 9 plus negative 3 is equal to 6. So this is 2 to the 6th power. And that is equal to 64. If we want to do 2 to the 9th divided by 2 to the negative 3rd, when we are dividing two expressions that have the same base, that's when we subtract exponents. This would be 2 to the 9 minus a negative 3. And 9 minus a negative 3 is 12. So we are looking at 2 to the 12th power. And that is equal to 4,096. Then we have this one that's a little bit more complicated. We're looking at 5x to the 5th, 2x to the 4th, over 3y to the 7th. I'm going to simplify this before I deal with the whole fraction being squared. That way I don't have to combine like terms later. So in my numerator, I have 5x to the 5th, 2x to the 4th. Those are assumed to be known to be multiplied by each other. So 5 times 2, that's 10. X to the 5th times x to the 4th, that's a case where we add our exponents. 5 plus 4, that's 9. So I'm looking at 10x to the 9th over 3y to the 7th. And all of that is squared. So what I need to do is square everything in that fraction. So we have 10 squared, x to the 9th squared, 3 squared, y to the 7th squared. 10 squared is 100. I have a power raised to a power. That's when I multiply. 9 times 2 is 18, so I have x to the 18th power over 3 squared is 9. I have another case of multiplying exponents. 7 times 2 is 14. So I have y to the 14th power. I can't simplify 109ths. And since x's and y's are different, I can't simplify those either, so I'm done. We're going to take a look at a couple more. Next up, we're going to look at a 3x squared y to the 5th squared times 2x to the 4th y to the 8th. So I'm noticing this thing in parentheses is squared, so I'm going to have to square everything inside. So that'll give me 3 squared times x squared squared times y to the 5th squared. That handles the square outside the parentheses. I want to multiply that by 2x to the 4th y to the 8th. Well, 3 squared is 9. X squared squared, that's a case where I multiply my exponents. 2 times 2 is 4. I have y raised to the power of 5 times 2 is 10. And I'm multiplying that by my 2x to the 4th y to the 8th. 9 times 2 is 18. X to the 4th times x to the 4th. I add my exponents that time, giving me x to the 8th. And y to the 10th times y to the 8th. I add those exponents as well, giving me 18x to the 8th y to the 18th. Finally, I'm looking at 24 a to the 24th b to the negative 3rd over 3a to the negative 3rd b squared times 6ab to the 5th. There are a lot of different ways to go about this, and the order in which you simplify things isn't as important as making sure you are combining your terms the right way. I'm going to start by simplifying my denominator because these two terms can be multiplied by each other, and that's just going to make things a little bit easier. So in my numerator, I'm going to leave that alone for now. 24 a to the 24th b to the negative third. In my denominator, I have 3 times 6, that's 18. A to the negative 3 times a. If I don't see an exponent on something, it's assumed it has an exponent of 1. Since these are being multiplied by each other, I add my exponents, and negative 3 plus 1 is negative 2. I have a to the negative 2, and then b squared times b to the 5th is b to the 7th. I'm going to deal with my 24 and 18 in just a minute. For now, I'm going to leave them alone. I'm going to bring back a rule that we saw on the last page, or sorry, 2 slides ago now. It was our negative exponent rule, and it said if we have a raised to the negative x power, that's equal to 1 over a to the positive x power. Well, if you think about it this way, if a to the negative x, if we think about it as a to the negative x over 1, then having a negative exponent, if you move it to the other side of the fraction bar, it becomes a positive exponent. That's going to be true if you have the negative exponent in the denominator as well. If you put it on the other side of the fraction bar, it'll turn positive. So I'm going to move everything with a negative exponent to the other side of the fraction bar, and that'll turn it positive. So right now I have an a to the positive 24, that gets to stay up top, b to the negative 3. I want to change that negative to a positive. So to do that, I flip it to the other side of the fraction bar, and it becomes positive. I have an a to the negative 2 in the denominator, but I don't want it in the denominator. I want to put it in the numerator so that a to the negative 2 becomes a to the positive 2. I have a b to the 7th that's already positive exponent, so it gets to stay. So what I'm looking at is 24 a to the 26th over 18 b to the 10th. And then 24 over 18, if I divide numerator and denominator by 6, that simplifies to 4/3. So this is going to simplify to 4 a to the 26th over 3 b to the 10th. You might be asking yourself, well, Amanda, why didn't you just subtract your exponents? Because when we're dividing, that's one of our rules, is that we can subtract exponents. You totally can. There's nothing wrong with subtracting exponents once you are at this stage. So let's try looking at it that way. If we had a 24 a to the 24 b to the negative 3 over 18 a to the negative 2 b to the 7, we'll leave that 24 and 18 alone for a second. So if I take my a's, because it's a fraction and fractions mean divide, I can subtract my exponents. 24 minus a negative 2 is 26. So I get a to the 26. For my b's, I take negative 3 minus 7, so that'll give me b to the negative 10. But I don't like negative exponents. I want to keep my exponents positive, so I'm going to move that b to the negative 10 to the denominator so that it becomes a b to the positive 10. And you'll notice that'll get me to the same place I was in the other way. By moving that b to the negative 10 down to the denominator, it becomes b to the positive 10. So there really are a lot of ways to attack these. As long as you're following the exponent rules, you're going to be okay. The last thing we're going to look at may be new to you. It's going to be rational exponents. We are going to be able to take square roots and cube roots and all these other different types of roots and write them as a power instead. So rational, also known as fractional exponents, allow us to represent radicals in a different way. If x is a real number and m and n are positive integers, then x raised to the m over n power, I know it doesn't look like it's raised to the power, but I promise you it is, That's going to be equal to the nth root of x to the m power, which is also equal to the nth root of x in parentheses raised to the m power. We're going to practice with these, and the reason we're doing this is that it's going to make our lives a lot easier moving forward if we have rational exponents rather than thinking of these always in their root form. So we're going to start off with writing some exponential expressions in radical form. So first up we have r raised to the 2/9 power. So it looks like this first one, x to the m over n. So according to this first one, I can write it as the nth root, where n was my denominator in the exponent, so this will be the 9th root of, it'll be r raised to the 2nd power. That's all I got. Next up, I'm looking at z to the -3/4 power. I'm going to think of this negative power as I did in the last slide. If I move it to the denominator, then it turns positive. So I have 1 over z to the 3/4 power, which will be 1 over. Now I can think of it like I did the very last one. My z is going to stay raised to the 3rd power, but I'm going to take the 4th root of it. Next up, I'm going to take these expressions from their radical form and put them in exponential form. So I'm going to do the exact opposite of what I was just doing. So if I have the 12th root of c to the 7th, whatever power this thing is raised to is going to be the numerator. So I'll have c raised to the 7. The denominator is the root. So I'll have c raised to the 7 over 12. Next up, I want to find the square root of 9tv cubed. Well, 9tv, I'm going to leave it in parentheses. That's raised to the 3rd power. We're taking the square root. If you don't see a little number here, this little number is called the index. If you don't see one, it's assumed to be a 2 because it's a square root. So that root becomes the denominator. So this is 9tv raised to the 3/2 power. And I'm just going to leave it like that. We're not going to take it any further. Finally, we're going to do a little evaluating. Our calculators are able to do this, and I'm fine if you can type them in your calculator, but I do want you to understand where it's coming from. So if we're looking at 64 raised to the 2/3 power, if we start by writing this in radical form, that will be the cubed root of 64 squared. Now I don't know what 64 squared is off the top of my head, but if I use this last little form, I could write it as the cube root of 64, and whatever that is, square it. I know that the cube root of 64 is 4, because 4 times 4 times 4 is 64. So what this simplifies to is 4 squared, which is 16. So that's a way I can do this in my head, is by simplifying the parts that I do know. Lastly, I'm looking at 4 to the -3/2 power. First, I'm going to deal with the negative power and write it as 1 over 4 to the +3/2 power. And then I'm going to use the trick that I just used. I'm going to write this as 1 over, this time it's going to be the square root of 4 cubed. I'll take the square root of 4, and I want to cube it, so that'll be 1 over 2 cubed, which is 1/8. So that's a little introduction to rational expressions. Make sure you get these rules down because they are going to be so important moving forward. You're going to need to know them.